In this video, we're going to look at how to prepare a solution using the dilution method. So we know that we can prepare a solution from scratch by dissolving a solid solute in a given solvent. However, we can also take an already existing solution that we call the stock solution, and we can remove some of it and add water to that. If we do that, we prepare what we call a diluted solution, which would have a lower molarity than our stock solution. So let's illustrate that by looking at this figure. Let's say that we have a stock solution that we've already prepared, so an already existing stock solution, and we need that same solution, but just at a lower molarity. Well, what we would do is we would remove a given volume of that stock solution, and we would add it to a new volumetric flask. We could then add water to that volumetric flask in order to produce a diluted solution. But there's a few things we need to know. In order to prepare the solution, we need to really know four things. We need to know what's the molarity of the stock solution that we're using, and we call that M1. We need to know what volume of the stock solution do we need to remove, and we'll call that V1. What molarity do we want our diluted solution to be? That's M2. And what volume do we want to end up with our diluted solution? We call that V2. So let's take a look at a problem and see if we can describe how to prepare this solution. Pause the video, read through this, and see if you can figure out how to answer this question. Okay, so here we're preparing a solution, 250 mils of a 0.350 potassium chloride solution, and we're going to be using a 0.600 molar potassium chloride stock solution. So the first thing we need to do is let's identify our variables, M1, V1, M2, and V2. If we read the question carefully, we'll see that our stock solution, M1, has a molarity of 0.600 molar. V1, what volume of the stock solution do we need to remove? Well, we don't know that, so that we'll call that X. We want our diluted solution to have a final molarity of 0.350 molar. And we want our final volume of our diluted solution to be 250 milliliters. So the next step, we can calculate for X, or V1, what volume do we need to remove of our stock solution? And to do that, we use what we call the dilution formula. Anytime we're solving problems involving dilutions, this is probably the best formula to use. M1 times V1 equals M2 times V2. So let's plug in our variables that we looked at previously. Our M1 is 0.6, V1 is X, M2 we said was 0.350, and our V2 is 250 mils. Now we just solve for X. And if we do that correctly, we should get 146 milliliters. So the question, that's not our final answer. The question says describe exactly how we would prepare the solution. So we need to write a few sentences describing how we would prepare this diluted solution. The first thing, we would remove V1, which is 146 milliliters. So we remove 146 milliliters of our stock solution, and we would add that to a volumetric flask. In this case, we're going to use a 250 milliliter volumetric flask. Now we can add water to that volumetric flask until we get to the 250 milliliter mark. And if we do that correctly, we should have prepared 250 milliliters, and that solution should have a new molarity of 0.350 molar. So now you try one, pause the video, and see if you can solve this problem. Okay, so first thing, let's identify our variables. M1, our stock solutions, 0.400 molar. How much of it we need to remove, we'll call that X. Our final molarity, we're told we want to make a 0.175 molar solution, and we want our volume to be 100 milliliters. Now we can use our dilution formula, M1 times V1 equals M2 times V2, plug in our variables, solve for X, and we get 43.8 milliliters. But now that's not our final answer. We need to remove 43.8 milliliters of the stock solution. We're going to add that to a new 100 milliliter volumetric flask, and then we're going to add water until we reach our final volume of 100 milliliters. And then we will have prepared exactly 100 milliliters of 0.175 molar sodium sulfate solution. So there's a lot of other uses for that dilution formula, so be sure you practice a lot of other problems to get more familiar with it.